Hi Internet, it's Jason here from Godlike Productions once more. Just going to run through another quick VSIG tutorial today. So we're starting off with some fairly simple ones. Last time we did the sample and hold LFO. I'm going to go back and do some more LFO tutorials, but with some more complications such as different shapes. And one of the ones that we need to look at is generating a sawtooth, because that is not a trivial issue. What we're going to look at today, though, is the envelopes that are available. So again, we're looking at modulation side of things at the moment and the interface. So again, we've got VSIG up here. We're going to run through this one relatively quickly, and I'm going to assume that everyone knows what an envelope is, or an ADSR. So we're going to run through the ADSR block today, and it's a relatively simple block. We'll bring up the help again, so Control D if you need to bring up the help at any stage. The ADSR as it is set up is really designed for processing audio signals. So the way that this really is, the way that it's supposed to be wired is something like this. So we've got two inputs that come into a mix block. Just knock this down a number so we don't get all the nasty little orange boxes. And then what's supposed to happen is this is supposed to go in through an input, and then this output goes out to wherever you want it to go. So it's a very simple envelope block, and you see what it does is it triggers, we'll wire up a trigger in a second, but what it does is that it essentially modulates whatever audio comes in through the ADSR block. And if you want to use it as an amplitude modulator, that's perfect. That's exactly what it's designed to do. That's not always what we want it to do, though. So let's start with the example of modulating the audio that we have in this scenario here. And you'll see what we've got down here. We've got a number of different like controllers here. So you can see we've got the attack time, decay time, the decay level, sustain time, sustain level, release time, and the re-trigger time. Okay, so what we can do is we can wire, let's start populating some controllers to control these as we normally would. So let's just go to our interface and let's get a number of knobs. So we'll start with an attack knob. So call this one knob attack. And we can see that let's just put it back onto here. I'll show you another little trick that we can do here. We can lock the documentation. So Alt, Control, Shift, and D. What this does is that when we change to different blocks, it doesn't change the documentation. So all of these, it goes from 0 to 10 seconds, or 10,000 milliseconds. And so we'll just leave this in milliseconds. So let's just go to this knob, and let's just go attack time, percent, and then what we want is it's going to be, we've got up to 5 figures here, so let's just go 5.0 F and then milliseconds. Okay, so again, just repeating what we covered in the last tutorial, we put a percent to say that we're going to put some control value here. 5 means we've got 5 decimal, we'll get 5 figures that we want to display, and then 0.0, so we want 0 after out of those 5 numbers, we want none of them after the decimal place. So this will display up to 10, or up to 99,999, and F is what substitutes in for these numbers and milliseconds. So we're not going to worry too much about tapering these. Like normally if you were going to design an envelope, you'd probably taper these somewhat because at the moment, to get to 10,000, you've got to go through 10,000 values, which you can scroll through pretty quickly, but it's linear, and usually what you want to do is that as you get into your larger values, you want larger steps between them. We're not going to worry about that at this stage. What we're demonstrating here is the envelope rather than the controllers. So we'll come back and we'll cover these in another tutorial at some stage. Okay, but for the time being, so let's just wire this one up into the attack time. Control C, so we want one for decay, one for sustain time, one for release time, and the retrigger time, we might just set that to a constant for a retrigger time. So we want 3 more copies of this, so Control V, 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 okay. Right, so this is knob attack. Let's change this to knob decay. T. This is attack T. So this is attack time rather than. Sorry. Decay. T. Oops. T. Make sure you press enter. And what we're going to do is we're going to change this to dec T. That's all done. So we can wire this one up to the decay time. This one here is going to be the sustain time. So let's just rename that. Sustain time, and this is going to be a release time. Okay, so what we might do is we might change some of these default times. So let's just change this to, let's do a decay time of 100 milliseconds, a sustain time of 500 milliseconds, and a release time of, say, 250 milliseconds. All right, so that's some default times that will come up. That's just so that we can sound, and we'll do this one to the release time. So now we've got 2 of them which are decay level and sustain level. So let's use a percent knob for these because these are sort of designed to do this. So the percent knob, it displays values from 0 to 100, but it outputs 1/100th of that. So it'll output from 0 to 1, for example. I think you can go for a negative. Well, you got a bigger range, but the output is divided by 100. Essentially. So let's call this one the decay knob decay level, and we want dec L percent 3.0, and then to display percent, you need to put 2% signs at the end. Okay, that's what we'll display. So let's put 0, and the maximum is going to be 100. And we want the attack time to default to 100. Okay, let's copy this one, and now we've got I think the other one we need is a sustain level. And let's just set this to 50% by default. And this is sustain level. Okay, so let's wire these up. Decay level and sustain level. Retrigger time, let's set that to let's say 100 milliseconds. So these are control signals. So we want to go up to control maths and bring in a constant. Again, I put my constants up the top. So let's just move all of this down a little bit. Oops. I wanted all of these, so let's try that again. Let's move all them down a bit. Start our constants up here. Again, my naming convention, so let's call this one here is going to be 100, and the value is going to be 100. Right, let's wire that in there. Okay, so if we now stick in a menu page here, stick it there, and let's call the menu page envelope CTL, and we want 1, 2, 3, 4, 5, 6. So let's put 6 here, and we can just wire all these up. Nice and easy. I'll show you the alternative way to wire these up actually. You can click here and then you've got a menu. This is one of the reasons it is so important to name things, except I've got two decay. This one here should be stain L. Alright, so now if we go back to this one, let's do it in order. So we want decay time, and then we want decay level. So put that one in, then we want sustain time, sustain level, and then we want finally the release time. Okay, and you find that this can, once you get a lot of blocks, you'll find that this type of menu diving is very useful. And that's why it's important to name your blocks, because that's how you find them. You see here we've got them named, so we know this is the attack knob. We know this is a decay level knob, decay time knob, release time knob. So this is why naming these blocks becomes very important. For little examples like this, not so bad. Believe me, they get way complicated and very confusing, and sometimes you do lose your way around. While we're here, I'll just show you a couple of other really cool features that we can do. So these S, C, and U's that you've got up the top, these turn on and off. So that's the audio lines. S, which I think is maybe sound, but they're the audio lines. C is control lines, they're the blue ones, and U is the pink ones. Note to Eventide, if you guys do an update of this, it would be really good if you can color code these. So blue, green, and pink. Just another little feedback thing for us. And so yeah, you can turn those on and off. The other thing that I find really handy is if you alt click on a block, what it will do is it will highlight that block, everything that feeds it, and everything that goes out of it. So I find this, and everything else, just everything that's not connected to this block gets sort of transparentified. So I find that very handy, and just to undo it, you just click on, just don't alt click, just click normally. One thing that we did forget here, so let's just add another block here. We need a trigger, because this, at the moment, this envelope doesn't have a trigger. Now you can trigger it off an audio signal, you could have an extra input come in and sidechain it off that if you wanted to. What we're going to do is, in here somewhere, there is a trigger knob. So we're just going to put this in here, and we're just going to call it env trigger. And this one is let's just call it trig. It's a statement. So I think the statement for this particular block, I think the statement appears inside the little box, and env trig is what it'll be on the outside. Okay, so let's just, now you see this is expecting an audio signal, and this is creating a, so if we try, this is a control signal. If we try and connect it up, you'll see it won't connect. Not going to connect. So this is what this mysterious little item called bridge is for. So we want to convert from control to audio. So see, I usually use the filtered ones. So C filter A, and the filter just, when things go on and off, it just tends to make them a little bit smoother. All right, so this, now we'll have a trigger that appears on the envelope one. So this patch as it is, once we sort out the order of the blocks, basically what's going to happen is you can play audio on your inputs, hit the trigger, and then you won't hear anything. As soon as you hit the trigger, it will run through the envelope. So you can shape an envelope. You can have, if you hook this up and trigger this by a note, like you could have a MIDI trigger here instead. Every time you press the note, it can trigger an envelope. So you can do things like stutter effects, tremolo effects, things like this with this quite simple output. You could, if you had you could have a level sensor here from an audio input. You get either these ones or a side chain, and you could essentially trigger a gate or a what's the opposite of a gate? I can't remember off the top of my head. My brain is a little bit fuzzy at the moment. But yeah, you can use this to do basically that type of processing. All right, so let's quickly put all these in order. So essentially what we want to do is the ADSR, let's just move this down the bottom, because we want that probably to be run as one of the last blocks. And the only other one that's out of order, you can see that we've instantly got rid of all of these orange blocks except this one. So let's just take this down to 9, and that fixes that. All right, so everything's in order. Let's just save this. Save as. Bring this across onto the display that you guys can see. All right, just ignore some of my other ones that we've got here. So this one, we're going to call this new folder, and this is envelope tutorial, which I can't spell, but you know, envelope. All right, that's better. Right, so this is a amplitude envelope, and rev A, because it's the first one I've done. Let's save it. Right, again, I'm going to upload these to Buy Me a Coffee, so all you guys that subscribe, you're going to get these for free. Everyone else, if you particularly want these, you can pay $5 for them and get them, or it's probably cheaper just to subscribe and get all the goodies. So yes, I'll upload these. Now, what we're going to do is we're going to convert this, and I'm going to show you how to use this envelope block with all the same controls. We're going to keep the controls the same, but how we can use this for something that is not amplitude modulation, because that's what it's built for. Okay, so let's say we want to filter this. Let's say we want to trigger a filter envelope on this, which is, you know, not an unreasonable thing, kind of like a wire pedal. So let's go back, let's go and find ourselves a nice little filter. So we go into the filters. The H9000 SPF's a nice filter. So let's throw this up here. Heck, let's do it in stereo. All right, so let's have 2 of them. And we can get rid of this mix block. We don't need that anymore because we're going to process stereo. So let's wire this into the input here and the input here. And we want to go from, let's do a low pass filter. Or how about we do, actually let's just put ourselves in a little mixer here. This is the one I want. Yep, this one will do. Let's just put, no, let's do stereo mixer. This one's a little bit easier. So let's do low pass left, low pass into the right, and then left into there, and right into there. Okay, we've got the gains and the pans. So I think the pans are, so let's just bring up that. I think that wants so pan is -1 to 1. So let's just do a left and right. We're not going to worry about all this across a bit. There. Right, let's do this one, -1. That's 1. And let's call this one constant 1. Oops, that's not gonna, well, it'll probably work, but let's type in what we actually meant. And so pan 1 is -1 is left. So we want that one to be left, and this one is going to be right. Let's just drop these down. Okay, and then let's just put we're just going to put a gain control here. So let's just make this menu page one more. Put a gain control, Control CV, because that's a percent knob, and let's just call it gain. And the gain for these is going to be, oh, we need -100 to 0. So this is in dB. So sorry, let's just delete that one. And let's just copy this one. This is called gain. Is percentage 2, 3.1. Oops. dB. And I think this needs Control D, -100 to 0. So let's just put the this knob needs to be -100. And this one is 0. We're going to do it in 1 dB, and let's just start off at -6 dB, which sounds like a reasonably safe level. Wire this into here, wire this in, oops, the block rule, and wire this into both the gains. All right, so now we have a gain knob. Let's just drop this down a bit. Right. Okay, so to just describe what we've just done. So we've now got the audio signal traveling through these filters, and we've got it so in stereo going to a stereo mixer that outputs it. We've got an extra control here to turn that up and down. Okay, so what we can do, these, let's just bring up the documentation for this again. So what we've got here is we've got a frequency and a frequency amount, and then we've got a frequency modulation amount, a Q, and a Q mod amount. So let's leave the Q modulation, we're going to leave that at 0. So we're not going to modulate the Q, but let's put a controller in it for Q, and we'll put a controller in it for frequency. And then what we're going to do is we're going to put a controller in for how much frequency modulation the envelope's going to impart. And then I'm going to show you how to make these envelopes, or how to make the envelope do something useful for us. So the envelope's going to live up here somewhere. Okay, so let's do these controls. We've already got a bunch of these. Again, we're not going to concentrate too much on the exact knobs. So this is cutoff. This is frequency. First, again, we're going to go 0 to, let's just go to 15,000. Yep, that's right. Let's just start it off somewhere. Let's not start it at 0. Let's start this at, I don't know, let's say 2500 hertz. Sounds reasonable to me. Okay, this can get wired directly into the filter, into the pitch of the filter. Okay, so that's going to control the pitch. Let's do another, this one here is going to be the freak mod. Again, hertz is fine, but this time let's do negative 15,000 to 15,000, and this time we're going to start it off with 0. Okay, this one we can then wire this into the pitch mod amount for both of these filters. And finally, let's do a resonance knob, or Q as they call it. We'll just call it res. And I think resonance in these is in dB, if I remember correctly. No, it's in Q, so we'll just call it Q because Q's kind of like the inverse of resonance, kind of. So the minimum we want is 0.5. The maximum this can go to is an unhealthy amount of 1,000. We might just run that up to 10. Just for the sake of this, because otherwise we can do bad things. Otherwise we can do bad things to our ears. We'll do the resonance in this in 0.1 dB. Actually, the units, and we only need 3.1. And the default of this, we'll leave it at 1, which is no resonance. Well, it's Q of 1 is generally no resonance. So again, let's wire these into the Q. Okay, and I'm going to pull these out the way. So if you hold down control, you can select a number of different knobs at the same time. So they are going up into these two blocks here. And we're going to give ourselves another menu page here. So let's just call this one filter. Cut off, and resonance. We're going to need another one of these. So let's say 2 kids. And we'll wire you into there. Another thing that I didn't point out is in this ADSR, it's actually got a menu item here. So if you just wire this up to a menu page, it'll show all these. You don't have to program all of these manually. It'll actually just show a preset menu. But it shows everything for this block. So if you don't, if you want to set something and have it not changed by the user, you're better off making your own knobs. But if you just, want something quick and dirty, you can use this one. If you want to show everything that's in that menu or all these imports, then sure, just grab the that object from the menu item. Okay, now for the sneaky bit to get this to control. So what we need to do is that we need to get something that does this pitch mod. Now, because this processes audio, what we need to do is that we need to go up into I think it's in the maths section. And so this maths section, this is all audio rate maths. And in here, there's a constant. Okay, so if we throw this constant up here, and so you can see these are C constants, control constants. This one here is an audio rate constant. Now, for full value, let's put 1 there. So that is a DC offset at full scale. All right, so I think if let me just pull this up so you can see it. You can see it goes from -1 to 1. Sorry, my banner was just in the way there. So what we want to do is we'll wire this into the ADSR input. And now what's happening is that whenever we trigger this envelope, the maximum level is going to be 1, which is, and you can do things like you can put multiplication over here if you want to do some other type of thing, but this is all built into the filter modulator. So by changing the pitch mod amount, changes the effect of this ADSR. So we can just wire this now straight into the pitch mod. So let's just talk about what we've done here. We've got a constant full scale audio output DC full scale feeding into this ADSR. When we trigger it, the envelope is going to ramp up to basically the top level, and then it's going to ramp down, do whatever the envelope does, and that signal is going to come out of there. So that signal is going to be between, because this ADSR goes down to 0, it's going to be a signal between 0 and positive full scale 1. And that, because this accepts audio rate modulation, we can put it into this pitch mod, which is an audio rate modulation of this. Alternatively, if we wanted to, we could just directly manipulate this pitch variable here. So we've got this cutoff knob, for example. So let's just quickly have a look at how we could do this. So let me just get some of this stuff out of the way, just so we can concentrate on the blocks that we need to be concentrating on. All right. So we're going to say, actually, let's just save this now. Save as, so this is filter envelope method 1. Okay, all right, save that. All right, so that's all wired up properly. Now, the alternative I was talking about is that we can directly modulate this pitch here instead of, so we've got a cutoff knob, and we've got a cutoff knob, and then we've got this modulation frequency. Okay, so what we can do, we can do a multiplication of, so we can add it to whatever your cutoff frequency is, and then we can do a modulation. So to do this, we're going to need a few extra blocks. This is all going to be in control space. Okay, so to use this, the pitch, what we're going to do is we're going to wire into these pitch control signals here. Okay, so what we're going to need is we're going to need a bridge, which is audio to control. In here, we just need one of them because we've only got one envelope. So let's wire that into there. And then what we need to do is that we need to, whatever value this is, we need to add to it whatever this frequency modulation is times by this envelope. So let's do those in order. Let's multiply these two together first. So this is control. We're in the control space here. So we want control maths, and we go down to C multiply. Throw this up here. Right. And we multiply those two together. And then we want to add that to whatever this cutoff frequency is, because we want to set the cutoff frequency, and then we want the envelope to modulate above and below it. All right, so we can do a C adder, put this up here, and we just want to simply add that, and then we can add that, and then we can simply wire these into the pitch. Okay, and then we can get rid of, in these ones here, we can get rid of the pitch modulation. We don't need this anymore, so disconnect that. We don't need the pitch modulation here, same here. Disconnect and disconnect. All right, again, we just need to put all of our blocks in order. So what have we got here? So this is number 12. So you can go there. We want to put, let's just throw these ones down the bottom. Should solve most of our problems. I know we need a mixer after that. Stereo mixer can go down there. Right, so all the orange blocks gone. So essentially what we've now got here in this other one, which I'm going to save in a second, essentially we've got this constant one going through an envelope, so, and then it's getting converted into a control signal, multiplied by whatever our frequency modulation amount is, and then we're going to add that to whatever our cutoff frequency is. And then that then directly controls this pitch. There's sort of upsides and downsides to doing it this way. One of the upsides is that this is probably going to use a little bit less processor time, because it's not going to be much, you're probably not going to notice it, but it will use a little bit less because the control frequency is updated at a lower rate than what the audio frequency is. The downside is that it's not going to track quite as accurately, but again, you're probably not going to notice it because unless you're not going to notice it by twiddling a knob. I don't think you're going to be able to move a knob at audio frequencies. But you can modulate audio frequency, so you can bring in another input here and modulate the frequency with audio at a higher rate. If you need it, you can certainly do that. All right, I hope that I haven't confused you all too much, but I just wanted to run through and just show really what we can do for using the envelopes, both for the audio, well, firstly for amplitude modulation, which is the easiest case, and then a couple of ways that we can use the envelopes to modulate other things by using this constant one trick. So we put this in and we just then use this as a source that you can use to multiply or modulate or feed into the modulation input of something else, which is an amplitude, in this case, a low-pass filter. All right, guys, as I said, I'm going to upload these on my Buy Me a Coffee site. It's going to be free to subscribers that support me and support this channel. And yeah, if you find this valuable, please consider joining up. I'm going to I think I'm going to continue along this series and, maybe work through some of the blocks, some of the tricks and tips that I've picked up as I have gone through this discovery journey of VSIG. Hopefully make it a little bit more approachable for some of the users out there that might be a little bit daunted by this spaghetti that you see on the screen. And, I have a certain way of thinking. I'm not sure if you're all going to relate to my way of thinking, but hopefully you can at least get some inspiration and maybe break down some of those barriers to embarking on the VSIG journey. I'd really like to see, what this can unlock for the imagination of all you audio professionals out there that have got this awesome piece of equipment, and you have almost certainly got different audio needs than what I have, and I'd love to see what other people come up with. And if getting an entry into VSIG is a barrier for that, I hope that I can break that down and make this a little bit more accessible to you all. I think that the community at large may be inspired by it. And again, from my part of contributing to the Eventide community, these are going to be available as building blocks. So, if in the future you need, a filter and a modulate thing, you can just import this. You can copy and paste all of this stuff. You can just copy it, Control-C, make a new window, paste it in here. Right, there you go. And you've then got little, envelope that you can use on your own patch. So that's really, partly for my use, because I'm going to use a lot of these. I reuse a lot of these pieces of code that I write, and I'm starting to build up a little bit of a library. But also hopefully this can give you guys some shortcuts so that if you guys need an envelope in the future, you don't have to program it. It's there, copy, paste, wire it up to do something awesome. So if we can save some time. In the old VSIG, there used to be a block called a super block, and I really hope Eventide bring it back. What a super block is, basically you can take this and you could right click it, or you could compile it into a super block. What that would do is it would compact all this down, and you just the only thing that would be exposed is all these inputs from, so basically you'd have a block with a whole bunch of inputs that would look a lot like this, and it would show up as a menu item in here. So if you wanted to do this envelope, you just drag it in and there'll be a block that's got all these inputs, a whole bunch of inputs that you can just connect up to your triggers, and all of this maths here will be hidden. You get outputs out of it and inputs into it. And so it just makes your code a lot more portable and readable. It's like, oh, there's an envelope there, right? You just pull it in one block instead of all this. But at the moment, this is what we've got. So patches tend to get large and unruly, and they look very, very scary. But they're really not. It's, you know, if you can wire up the back of your rack or a modular synth, you can probably wire this up. It's not really that dissimilar. You just, you know, think about a cord. You're plugging one end in here and you're plugging the other end in there. You want this to control that, like a MIDI cable. So anyway, thanks for tuning in, and I hope that you guys get something out of this. It's been a little bit longer than I was hoping, but yeah, we've covered a lot of territory. So just a summary of what we've covered. We've used the ADSR block to look at envelopes on the envelope on a level, and we've then looked at two different ways that we can use an ADSR to control something, in this case a filter. And that's basically been it. We've covered the knobs, we've covered triggers, we've covered some bridge items, we've covered constants again, covered the SVF block, we've covered the stereo mixer, and again we've covered menu pages. Alrighty guys, thanks a lot. If you like what I'm doing, please subscribe to Buy Me Coffee or my YouTube page, or follow us, or, you know, do what you do if you want to find this stuff easily when you know, launch up your YouTube, and subscriptions do the thing. If you just like to chance upon us every now and then and check back, don't subscribe and check back. Alright guys, thanks heaps for oh, pardon me, I should have got some water. Thanks heaps for tuning in. I will see you all next time. Bye guys.